The money in the utility MIU model, originally developed by Miguel Sidrowski in 1967, is a foundational framework in financial economics and macroeconomics. It addresses a fundamental question: why do people hold money when other assets, like bonds or capital, pay a higher interest rate? In this model, money is assumed to provide direct liquidity services, e.g., ease of transactions, reduced search costs, which are captured by placing real money balances directly into the household's utility function. 1. The model setup. We assume a representative household that lives forever and seeks to maximize its lifetime discounted utility. The objective function, the household maximizes, where C_T, real consumption at time, T.M_T, real money balances, defined as frac M_T, P_T, nominal money M_T divided by price level P_T, beta. Subjective discount factor, 0 less than beta less than 1, reflecting how much the household values future utility compared to the present. U times, a utility function that is strictly increasing and concave in both arguments. The budget constraint. In each period, the household receives income from production, transfers from the government, and returns on assets held from the previous period. It spends this on consumption and acquiring new assets. The flow budget constraint in real terms is: explanation of terms, K_T plus 1. Capital for the next period, B_T. Real bonds purchased at T.F of K_T. Production, output, using capital, delta. Depreciation rate of capital, 1 plus pi_T. The gross inflation rate, P_T by P_T minus 1. I_T minus 1. Nominal interest rate on bonds, Tau_T. Real lump sum transfers from the government. 2. Mathematical derivation. To solve this, we use the Lagrangian method. We define the Lagrangian mathcal L by summing the discounted utility and the budget constraints for all periods, multiplied by the Lagrange multiplier lambda_T. Step 1. Formulating the Lagrangian. Step 2. Deriving first-order conditions, FOCs. We take partial derivatives with respect to the household's choice variables, C_T, M_T, K_T plus 1 and B_T. 1. With respect to consumption, C_T, closing parenthesis colon. Explanation. The marginal utility of consumption at time t must equal the shadow value, marginal utility of wealth, lambda_t at that same time. 2. With respect to capital, K_T plus 1. Note that K_T plus 1 appears in the constraint for period t as an expenditure and in the constraint for period t plus 1 as a source of income. Dividing by beta to the power of t, colon. Explanation. This is the standard Euler equation. It says that the cost of giving up 1 unit of consumption today to invest in capital must equal the discounted benefit of the extra output and remaining capital tomorrow. 3. With respect to bonds, B_T. Similarly, B_T appears in the period t constraint and the t plus 1 constraint with interest. Dividing by beta to the power of t, colon. Explanation. This links the nominal interest rate and inflation to the marginal utility of wealth. Note that frac 1 plus I_T 1 plus pi_T plus 1 is the gross real interest rate, 1 plus R_T. 4. With respect to real money balances, M_T, money appears in the utility function and the budget constraints. Dividing by beta to the power of t, colon. Explanation. Holding money yields direct utility U_M but also has a future value in the next period's budget, though that value is eroded by inflation. 3. Combining the equations. To find the money demand function, we substitute equation 3 into equation 4. From equation 3, we know. Substitute this into the last term of equation 4. The 1 plus pi underscore t plus 1 terms cancel out. Factor out lambda underscore t, colon. Finally, substitute lambda underscore t equals u underscore c underscore t, m underscore t, m underscore t from equation 1. The result, marginal rate of substitution. This is the money demand equation. It states that the marginal rate of substitution, MSS, between money and consumption must equal the opportunity cost of holding money, which is the nominal interest rate, adjusted for the fact that money is held at the end of the period. 4. Economic intuition. Opportunity cost. Every dollar held as cash is a dollar not invested in a bond. The interest you lose, I underscore T, is the price of the liquidity services money provides. The Fisher equation. By comparing equation 2 and equation 3, we see that 1 plus R underscore T equals frac 1 plus I underscore T 1 plus pi underscore T 1 plus pi underscore T plus 1, which is the standard Fisher relationship in financial economics. Superneutrality. In the Sidrowski version of this model, if the utility function is separable, U underscore Cm equals 0, changes in the growth rate of money only affect inflation and the nominal interest rate, but not the steady-state levels of real consumption or capital. This is known as the superneutrality of money.